Let me open mine. Sorry, my internet just shut down for no reason, but we'll fix it.
We're good. All right, so there we go. We're good. We're recording. I'm getting into the quiz right now too, so we should be just fine. Here we go.
Okay.
Hey, Brian, I let them know that I'm facing this way, but I'm totally paying attention. I'm just looking.
Oh, I saw that. Don't you worry. You're good.
Okay. I'm not watching Netflix or anything.
Whatever you got to do this. Okay. Okay, well, you're required to work together on each quiz. Each member of the group must submit his or her own. Yeah. Read that before. Okay. Proportion of this. Okay.
Did you see at the top where it's asking for our answers in decimals, not in percentages,
Yeah.
right? Okay. Just making sure everyone saw that.
Okay. Keep that in mind. All right. The blood types and proportions given in this table define a probability distribution. I am going to say true because it adds up to the number 1.
Yes.
Yes.
Okay. All right. There's a probability that a randomly selected person in the U.S. has a blood type of O.
And that would be 0.45, because if they equal up to 1 or 100, that would be 45%.
Okay, so you just minus it, right?
Well, no, the table actually gives you the distributions. So if you just look back up at the chart, it gives you the probability, the proportion for O, and that's actually the probability of it. Yep.
Okay, so it's 0.45.
Yep, 0.45. Okay. And then the next one is what you just brought up. So the probability that a person does not have 0.45 or does not have O blood. So it's the rest.
So then you would just minus it from 1.0.
Yep, 1
Yes.
minus 0.45. Yep. So we're just going to cool 0.55.
Do we have to put a 0 between the point, or is everyone just doing point and then 55?
Judging by the.
I'm just putting point.
I don't think that's going to affect it. It does say in the example answer, though, that it should be 0 point, so maybe it would be worth just adding that. Just to make sure we don't run into it. So 0.45 and 0.55. Okay. Right. Dogs with bladder cancer. Dogs are trained. Lie down, derived bladder cancer patient. What the heck? This is weird.
Okay.
It would be just like a die. If there was 7 numbers, so it'd be 1 over 7.
Yeah, so we just need to calculate what 1 over 7 is. Does it say to what place? Round the answer to 3 decimal places.
Yeah.
Okay.
And then, so it comes out to 0.1428, so you round up 1 or 0.143.
Mm-hmm.
That's what I got as well.
All right, and we're putting a 0 before the point?
Yeah.
Okay.
Yes.
Combined of 54 trials, the dog correctly identified the specimen 22 times. It's very unlikely the dog would do this per random choice alone. Which of the following statements is most appropriate? What is...
What's
little? 22 divided by 54? That's a lot more than 1/7. So I would say it proves that they can detect it.
Because that's almost half.
Yeah. Yeah, that's right.
That would work out to be about 41% of the time.
Yeah, that's a lot more than the 15% if you round it up. Yeah, 14%. Yeah. M&Ms are smart. Small chocolate candies is good information.
Learn
Okay.
something new.
Yep. If you read this, for each individual bag of M&Ms, what's the probability of drawing a red-colored candy?
Hey, I'll be right back.
Yep.
Okay.
You're good. Point
Gotta
one.
make sure my dog's not ripping up anything.
All right. It's being awful quiet, so must be doing something.
Hopefully something right.
Yeah, that's the dream. So yeah, we have 0.13 for that one because it's just from the chart. And then to calculate the next one for the green ones, we have to add up the ones we have, and then it's 1 minus that. So it'd be 1 minus 0.84, which is 0.16.
Okay, sorry. Are we on 8?
We're actually on 9. So 8, the answer is right in the chart. The probability of red is there in the chart. And
Oh,
then,
so 0.13?
yep.
Yes.
Okay.
And then for the next one, you're just adding up all the values and doing 1 minus that value.
Okay.
And that gives us 0.16.
Okay. All right, thank you.
Yep. So now, probability
you
of getting a
just-
candy that is
oh.
not green.
No, it's just the exact opposite you took.
Yeah. Well, you add it up, right?
You add up
So-
everything.
Yeah, add to what you had.
0.84 is what we have.
8, 4. Okay. So are we all on 11 now?
We are all on 11. Okay. ACT scores of students, medium-sized university, Western United States, for taken from CAPEX, following summary statistics. Half the observations are less than or equal to what number? Oh, gosh. Oh, so it's the 50th percentile. So that's the median, isn't it?
I think so.
Yeah, because
Yeah,
the first,
median exact middle.
Mhm.
Yes.
So
Yep.
24, right?
uh-huh.
Yes.
So based on the answers above, the top 25% scored how much? At least how, or at the most how much? So that'd be the first quartile.
Top.
That would actually be the third quartile because the first quartile is
Oh, it's
usually
the top 25. Yeah.
yes. So it'd be 27.
Okay.
Oh, yeah. Okay, gotcha. Good thing that yeah. Which of the following statements is not one of the three rules of probability?
The probability is high and the probability is positive. That's definitely not it.
Yeah, because then it talks about it being negative, so that's
Yeah.
not it.
Wait, which one is it? Sorry.
So
the third.
Yeah. Oh, yeah. Probability is higher than probability. Okay.
So
That
it's
is-
C, right?
It'd be C. So if the probability is high, then the probability is positive. If the probability is low, then the probability is negative. So that'd be
Okay, yeah.
the third one down. And look at that. We finished the first quiz.
In 10 minutes.
nice.
All right, who wants to submit it first?
I'll submit it.
Okay.
Okay, save my responses. Go to submit quiz. And submit. Yes. And, well, look at that. First try. All done.
Perfect.
All right.
Awesome.
All right, lesson 5.
Okay. So we're going to go into the lesson 5 group meeting quiz. Start that. Yeah, so if the lessons are like this, I think we'd still be able to do two in one meeting. I think the
Mhm.
first week was actually longer by quite a bit. So I don't know how long it's going to stay like this, but as long as we can kind of hold it, I think it'd be good.
Yeah, makes it a lot easier.
Yeah. When calculating anything, please remember to round to 3 decimal places unless otherwise specified. Do not round until your calculation is complete. Okay. This quiz is how long? This quiz is a little longer. This quiz is 18 questions.
Yes, and you'll need to click on the normal probability applet at the top.
Yeah.
Oh, I
Okay.
see.
So I'm going to have that up here.
Yeah. Not up.
Put that down there. Okay. I had a really, this thing was funky for me. I don't know why. It just didn't really click for me, but
Same for me.
you
Yeah,
look at it together. Oh, this is going to be great. None of us understand. Okay.
Hopefully we can figure it out together.
Total area under a normal distribution curve must equal, this is the part where I look at my notes because
I believe the answer, when you use the little normal, oh no, wait. Well, when you use the link that they provided, when you put area as 1, it shades the whole thing. So
when
I
you
don't
put the area, okay. But is that what a normal one is? That's the,
yeah, because it's a bell curve.
oh, okay. So it would just be 1?
Just one.
I think so.
Well, we'll find out. We get another try.
Yeah, I was gonna say we get 2 chances.
Under
Under
certain
certain circumstances, the normal distribution curve can drop below the x-axis.
under normal circumstances, I'm going to say no.
No.
Yeah.
It's a probability.
So,
Yeah, we just got a quiz question that said probability can't be negative.
yeah.
I'm gonna go with that as well.
Okay.
Normal distribution curve is symmetric.
If it's normal, then yeah.
Yeah.
Okay. Represents a z-score.
Okay. Which of the following figures represents the z-score?
Wouldn't it be... I feel like this is a trick question. Wouldn't it be C? Because if you look at the one that we pulled up, the z-score is the numbers at the bottom.
Yeah. I don't think the z-score is actually in the curve.
But the C points to the
Yeah, that's what I mean. That's like I think I'm pretty sure what you're saying is right. But who knows? It might be none. Hold on, I'm trying to. Where's that app thing? Yeah, it is the z-score.
Right.
Yeah.
Okay, so C.
Yeah.
Yes.
All right,
Even if you
that's
just
what I
open the applet on the bottom, it says z-score right next to the space.
Yeah, that's what I was like looking at. I'm like, it says z-score when you open the one that they gave us. So I'm like, I feel like that was a trick question.
Which of the following elements in the figure represent the probability of the z-score? All right, so that'd be everything to the right of the red line, right?
So
B.
B.
Yeah.
Right?
Okay. According to the rule with all the numbers, what percentage of the data from a bell-shaped distribution will be within 1 standard deviation of the mean? Okay.
And this one they want is a percentage, not a decimal.
Okay. So I'm looking at the part that describes the rule.
Shut up, Bronx.
Percentage of the data from that will be within one standard deviation.
Sarah, I'm not a ton of help on this one.
Oh, so in the textbook there, there's a section about it. It has 68% of it being one standard deviation away from the mean. So there's 60.
So it would be 68.
Yep. So the rule is 68% of the data will be 1% or one standard deviation away from the mean. 95% will be 2 standard deviations away. And 99.7 will be 3. So that's the rule. That's why it's 68, 95, 99.7.
Okay.
So 68, correct?
Yep. So you just write the number 68.
Okay, normal probability.
All right. So now we go to the normal probability output.
Between -1 and 1.
So between -2 and 2.
Oh, sorry. Did I miss question 9?
Oh, sorry. I skipped to 10. All right. Yeah. -1 and 1. That's the area that's right there on the number on top, right?
I think so. Because it already has -1 and 1 on there.
Yeah, so it's marked accurately, and that gives the area, so I would assume you just put that decimal.
But they went in 3 decimal places, so
So it would still be 317.
yeah, 0.317.
Okay.
Okay.
Able to, yep. So we're able to drag these lines.
So 0.05. For the
No, you
area.
can still do it because it's 3 places, right? So it would still be 047 because you just take the.
Sorry. Wait, did I miss 10? I thought we did -2, and I thought we were on -2 and 2.
No, yeah, no, that's what I went to. We just
okay.
did. Yeah, so we just did 9, and that was 0.317, and then you open up the app again. You grab the red lines and you drag it to -2, and it'll stay symmetrical. So if you go to -2, the other line will go to 2, and then just take the area number that's on top, and that's your answer.
Yeah, so it's 0.0455, so that would be 0.055.
Wait, did you not get 0451?
That's what I
goodness.
got as well.
Oh, maybe mine. I don't know.
See, yeah, I never know how to. Oh, what in the world? Hold on. Yeah, so you can just put 0.5045 or 0.46 if you round.
It looks like though on the negative side there's like a 4 in there.
Well, yeah, if you go to the z-score number on the very bottom, if you just put the number 2 on the left z-score, it'll line them up for you. So you can drag the line, or you can type in the z-score number.
Oh, okay. Because I was getting 0.0451, but yeah, 0.045 or 0.046. Okay.
Okay,
Yeah,
so it's
because it ends up being 5.5 once you finish it. So 0.046.
So the same goes for the other one. You just gotta drag it to number 3.
So yeah, so I would actually just type 3 in.
Yeah.
That'd probably give us the most accurate number.
So 0.003.
Yeah.
Yep. Okay, look carefully at the answers to the last three questions. What do you observe?
Hmm.
Hold on, let me look back at the
I want to say it's B, but I don't know.
So stored in.
I'm trying to see how the three options. I don't think it's the first one, even though the numbers. Actually, wait, it might be. Yeah, because we went 1, 2, 3. So that's
Right.
three. So that's three
It's-
standard deviations.
Right, and it's not the second or third one for sure. Those don't.
Yeah. Yeah,
Just
no.
check those.
It'd be,
So
it'd
it
be the
has to
first
be
one.
the-
Then. That's the
Yeah.
68, 95, 99.7 rule. Because it
Yes.
slowly branches out. I would, Trevor, just because of the review part in the chapter, I would at least look at that part over the rule because it gives a pretty good picture of it
Okay.
and explains the rule a little bit. Just so, 'cause I know you didn't get a chance to look at that lesson all the way.
Yeah. Not at all. I thought we were just doing 4.
Oh, okay. Okay.
From now on, plan on both.
Yeah.
Okay.
We'll probably end up doing that next Tuesday. Just doing both of them.
Sounds
All right, 13.
So this data is going to give us the last questions in the quiz. All right. The amount of protein.
Sorry. What did we have on 12?
12 is the
A.
first one, so it matches the 68, 95, 99.7 rule.
Okay. Thank you.
Okay.
Proportion of the population have a protein requirement of less than 0.6. Oh, what proportion of the population? Okay. So
Less than 0.6. Let's see. The mean.
protein requirement is given in terms of the number of grams of good quality protein that be consumed each day per kilogram of weight. Population mean the protein requirement of adults is 0.65 and the population standard deviation is 0.7 or 0.07. So, gosh. I hate working backwards with this.
If I remember correctly, at the bottom of this lesson, it had a formula for this. I think it was value minus the mean, and you divide the standard deviation from it. Let me look at the lesson. So
yeah,
I think
I'm
that's
looking at it right now. That sounds right.
okay. I think that's what we're supposed to do.
So the value is 0.6 minus the mean, which is 0.65. And then you divide that by 0.07.
Yeah, I believe so.
The only thing that gives you a negative number, or am I doing that backwards?
No, I think that's right. Let me look. There's less than this. Maybe it's not that. I don't know. Sorry. Let me look back at the lesson.
Because there's an equation following it. What is the proportion of a population at 0.6 grams? And it's probability times kilogram to the -1 times what's D. D is the body weight, D to the -1. So that's what I'm trying to. All right, this might be the quiz that kills us, guys. This is going to be great.
I'm going to pull up the book here.
Yeah.
Me too.
Um, that's SPSS information, so that's not what we're looking for. Yeah, because we don't have a data set, so it's not like they're asking us to make a plot to get the information. Wait, if you calculate the z-score of a value, it tells you how many standard deviations from the mean a value is given. So if we use that number, because I got like -8 point something, if we multiply that number by 0.7, that'll give us the number of standard deviations that we are away from the mean. So we have the mean, we have the z-score. So wouldn't we just, hold on, let me see if this is making any sense to me. So I got this 8 point, and then a really long number. So I take that number, I multiply it by 0.7, because that's the standard deviation. And that gives me negative, no, because that's still not right. Oh, it's 0.07. So multiply that times 0.07. That gives me negative 0.608. So would I take then the mean and subtract this number from it, or add this number to it?
I'm not really sure.
Is that making sense?
I see what you're saying. I'm not, but we still ended up with a negative number.
Yeah, because that's
sure.
the distance it is. That's the distance it is from the mean.
From the mean. Okay.
Yeah. And
So
the
then
mean
we
is
want
0.65.
from that number. So then we want from the number you just calculated and the everything below it. Is that?
Yeah, because we're trying to get people who need less than 0.6 grams of protein
Okay.
a day. So I think it's 0.65, and then you subtract 0.608. I'm gonna say it's 0.042. That is my answer. I don't know if that's right.
What'd you say, 0.042?
Yeah, 0.042. I think, but I'm not sure. That might be one that we end up having to recheck, but
Get two chances.
yeah, your z-score gives you the distance, like how many standard deviations you are from the mean.
Right.
So if you're -8 standard deviations from the mean, take the mean, multiply it by 8 point whatever, and then subtract that number from the mean. I think that's how you do it.
And then the next one, it's more than.
It's more than that, so it'd be just the inverse of that percentage. So it'd be 1 minus 0.042.
.958.
I think, I don't know.
That's
It would make sense if we're doing it the right way. I just don't know. I never know how it works with these quizzes, only because it's like, if our first number is wrong, then our second number is going to be wrong.
Yeah.
But that doesn't mean that the process was wrong for getting the second number. I don't know.
Right.
Yeah. Well, I don't know. We'll figure it out. What proportion of the population have a protein requirement that is less than 0.7?
So it'd be like
we
did for 13, but with 0.70 instead of 0.60.
Yeah, so we'd have to put in the value again. So it's the Our value is 0.7.
And then we subtract the mean.
Yep, subtract the mean. Subtract 0.65,
Okay.
and then you divide it by the standard deviation, which is
0.07. Okay. I have 0.714.
So wait, so you subtract the 0.7, or you get 0.70, and then you subtract the 0.65.
yeah, so your
Yes.
value minus mean, and then you divide that by 0.07. You get a really, really small positive number. So you take the z-score then, and you multiply it by the standard deviation, which is 0.07 again. That gives you 0.05, and you add 0.05 to the mean, so it'd be 0.7.
Mhm.
Does everyone else get that?
I
I
think so.
I didn't get the last part of what you were doing where the last two steps where you multiply.
So the answer that you get is the z-score. All the z-score is tell you how far away, how many standard
Right.
deviations you are from the mean. So you just take your z-score, multiply it by the standard deviation, and if it's a positive number, you add that number to the mean, and it's a negative number, you subtract that number from the mean. Does that make sense?
Yeah. Wouldn't
Yeah.
that
Well,
wouldn't
either
that
way, you
always
would
give
add
you
it.
your so wouldn't that give you your original number though, because we have subtracted because of the formula that we used to begin with? Like we divided by the standard deviation, so if we multiply it, it undoes what we just did. And then
Yeah, which
adding
is- I don't know.
Okay.
The only thing I see from here is it just says in the textbook, I'm just reading the thing, it says the z-score tells us how many standard deviations away
Right.
from,
Right.
which is why, yeah, I do think it's kind of weird. I think it's just for if you want just the z-score or if you want the value. But
Okay. Okay.
yeah.
I really wish these were multiple choice instead of fill in the blank.
That would be better.
Be a lot better. Okay.
So then what was the end result of all that? It was 0.7, right?
Yeah, I'm gonna do it one more time to make sure I did it right.
Okay.
So I guess we can just follow it along. So our value for this question is 0.7. So 0.7 minus 0.65. That gives us 0.05. We divide that number by 0.07. And that gives us 0.714 something.
Mm-hmm.
And then you take that number and that gives, so this number is our z-score. And we multiply it by 0.07. Correct?
Yes.
Okay. Yeah, 0.05. I think it's only because if the z-score is negative, it does end up turning into a different number. I think, but I don't know.
I'm just grabbing paper. I'll be right back.
So is 15 points 0.7 or 0.05?
I think it's 0.7 because you
Okay.
get 0.05 and then you have to add that number to your mean. And then that gives you the value. So our mean is 0.65. Yeah.
Okay. All right. Now I got it.
Okay. Sure. Point. Hey guys, I just had a really good epiphany. Since there's 4 of us taking this quiz and each of us gets to submit it once, we have a lot more technically than 2 tries. So what if I just submitted this right now without us doing the last 3 questions and we just find out and we ruin the suspense for everybody?
Sure.
Does that sound like a thing we could get behind? Okay.
Yeah,
All
for
right.
sure.
All right, so I'm going to submit mine right now, and we're going to take a look at those answers. I'm aware that I have 3 unanswered questions. Okay, submit. We are going to go on down here. Yeah, no, we got all those wrong.
Oh,
Oh, excellent.
What in the world? We're missing quite a bit, guys. This is going to be quite the quiz.
Uh-oh.
More than just the end, like throughout
No.
the quiz? Oh,
9, 10, 11,
dang.
13, 14, and 15. So pretty much every question where we had to write in the number, we got wrong.
Excellent.
no.
Okay. Now, how did we get 9, 10, 11 wrong? We just had to like type in the score.
That's
Aw.
what I thought.
I feel so bad. I'm like just piggybacking off you guys right now.
Oh,
Well,
I just thought of something for 9, 10, and 11. So it highlights what's beyond. It doesn't highlight the portion that we
It
actually
should be
want.
the inverse of
Numbers,
it.
does it?
Yeah,
So-
it should be the inverse of it. Yeah.
Okay, so that's all right. Okay, now we know
Figured
9.
that
At least we know that. Okay.
out. Okay, so I'm going to go back into the quiz, and I'm going to need you guys to get me all caught up on this.
Okay.
Start that.
Okay.
Okay, yep, and yep. Total area, can someone just walk me through from question 3 on?
Yes.
Okay,
So question 3 is 1.
all right,
Question 4 is false.
okay,
Question 5 is true. Question 6 is C. 7 is B.
Yep.
8 is 68.
Yep.
And then 9 we got wrong.
okay. So what was the answer that we originally put in for 9?
0.317. Could it
Okay,
be that we
so-
put the 0 before all of these?
0.317?
Yeah.
No, so when
No, I
we
think-
when we put in the numbers, it only highlights what's beyond those points. So when we put 1 and -1, it highlights the edges of that and not the inside portion, which is what we actually want. So just take 1 and subtract the number
Yeah.
we.
How did we not get this right? The question that asks us to evaluate the 3 answers we give asks us if this follows the 68, 97.
And it does, because that's
And
the
it
portion
does.
you're getting.
So it's 0.683 is the answer to number 9.
Yep. Yep.
So you said 0.683?
Yep.
Yes.
Can you explain why again?
So it's what? Yeah, go ahead.
Oh, so when we put in 1 and -1, what it highlights is the outer portions of that bell curve. It doesn't actually highlight the inside, which is what we want. So the number we have is just the outside. So just take 1 and subtract that, and then we have the inside measurement.
So how you would get the answer is you take 1.0 minus 0.3173?
Correct.
Yep.
Okay.
Correct.
Yep.
So we just kind of did the opposite.
Yeah, we just did the opposite. I'll be right back.
Yeah. So then the rest of the numbers would be the same. So 1 minus 0.046.
So 9 is 0.683. Is that right, Megan?
Yes. Yes.
Okay.
Sorry.
So now
Yes.
we're on 10. Right?
So then yes. So then I think, let me just check it with the chart. I think we had rounded some of these. So let me see what, let's see.
So for the next one, 10, I got 0.9545, and they want it in 3, so it would be 0.955.
Yes.
0.955. Okay.
Yeah, so 0.955.
Yep, it's following the rule.
Yep.
So now we'll do it for 3. Which, okay, so the next one would be 0. 0.
0.997.
Yes. Sorry, I was drawing a blank there for a second.
Okay, so we have those three.
0.997.
Which makes 12 make more sense because now it actually does follow the rule, like literally.
Yep.
So,
Yes.
okay. Now
That
we know.
was for number 14.
Yeah. So now we're
Well, now we're at 13.
13. Now we need to fit. Well, I still don't know how to do that.
Yeah.
Okay.
Let's
I think we're
see.
supposed to use that applet. I think
You
that's
think?
what we're supposed to do. Yeah, because we just calculated the z-score. Z-score. I'm assuming it's a normal distribution. Hold on. No, because it would tell us if we need that.
I need to grab my charger. One sec, sorry.
Yep. Yeah, I'm looking at this lesson, the textbook thing, trying to figure out what in the world it wants to do. Oh, so section 3.2 is called converting a z-score to a probability. So we're trying to calculate for the z-score. Hold on. Here's an example of this. Okay. Call that for the height. The mean is 159. The population is 4.2. Yeah. So if you go into your textbook for lesson 5, there's a section 3.2. I think that's what we're going to need to figure this one out.
For me.
3.2, let's see.
Yep. So it's converting a z-score into a probability. Wow. Oh
okay.
yeah. So we are using normal probability applet. It says that at least in the textbook.
Okay.
Yeah. So maybe we do just calculate the z-score.
Okay.
What did we get for those values again?
So let's see. So the value is, for the first question, 0.6.
Yep. So the value is 0.6. We subtract 0.65, correct?
Yeah.
Which is negative 0.05, right? Is that?
Yep. And then we
Okay.
divide that by the standard deviation, which is 0.07. According to the information that we have on top of the section. That's our z-score.
Okay.
Did you guys get a negative number?
Yes.
Yes.
Okay.
We should. Hint, remember that you're trying to find the area between two values. Shade to the left of each z-score, and you calculate, hold on. So I'm trying to read the last part of this question so I understand how to do it correctly.
we're on 13, right?
Yes.
Oh, I'm sorry. I'm reading a totally different thing. Yeah, I was scrolled too far down. Yeah, forget what I said. Yeah, 13. So we have the z-score. All right,
Okay.
so now it says type the z-score into one of the two boxes in the horizontal axis of your graph.
Oh.
And we're only going 3 decimal places. So we are doing negative 8.686.
I got a different number from that. Hold on. I'll check
Okay.
my math.
Where I haven't done this chapter, I wonder if I should just submit mine, do the reading, and then go back and submit this quiz.
Maybe.
I almost feel like I should.
It's up to
Okay.
you. I mean,
Yeah, it's your call. I mean, this quiz isn't due until Thursday. So,
Right.
we're all, I mean, in reality, we're all kind of struggling, so we're all learning together. I mean, it's up to you.
this is just
Let's see. Yeah, I'll just do that. I feel like
Okay.
that's a little more honest.
alrighty. Your call.
I'll talk to you guys soon.
All right, you take care, Char.
Tuesday.
Bye.
Yep, see you Tuesday.
See ya.
Bye. Okay. All right. So this is how I got my number, but mine's different from yours. So you take the value, which is 0.6, minus the mean, 0.65. Then you divide that by 0.07, which I got negative 0.71428 something something.
That's what I got.
That's what you got?
Yeah.
Okay, how the heck am I doing this that it is not just cooperating with me? Let me try something else. Maybe it's just the calculator I'm using is. Oh, yeah. I think it's just because it was dividing 0.65 by 0.07 and then subtracting it. Okay.
Okay.
Yeah, the calculator's just being weird with the. All right, so yeah, that makes this a lot better.
Okay. So then we take that number and we put it as the z-score. Is that right? So
Yeah.
7.14. I guess 7.14.
Or 0.714.
Yes.
Are we
Sorry.
doing it negative, or do we just...
Either,
Well,
you can do it on either side.
Yeah, it'll
Make it.
So are we
Yeah.
using the applet? Is this what we're
Mhm.
doing?
Yeah.
Okay.
Okay, and we are
So
doing everything.
So for the z-score, we type in 0.714.
Yes. Correct.
Okay.
Yep. And then you see how there's two blues on either side?
Yes.
You want to click the blue on the right so it unhighlights it.
Okay.
And
There
that
we
gives you the area just for everything at or below the number that we have.
Okay.
So now our answer is the area that's on top.
Awesome. 0.238.
So our answer is 0.238.
Okay. Yes.
Okay.
Okay, we are finishing
That's
the second thing.
that's for 13, correct?
Yes.
Okay.
Hopefully
So
we've done it correctly now.
0.238.
So now actually we can stay. We don't even have to close the applet. So keep the same numbers in because now we're calculating for everything that is more than that. So we can
Okay.
So
we can just unhighlight the one on the left and highlight the two on the right of that first red line.
Okay, so 0.762.
Yes.
Yep.
So that's 14.
Yeah. You could do it that way, or you could just do 1 minus the answer we just got.
Oh,
Okay.
that works too. 762.
Yep. Okay.
Do you want me to submit it to see if we're on the right track?
Sure.
Okay, let me submit really quick.
Hopefully we are.
Yeah, we are, because Megan, you're our last one after this one.
So hope that it works.
Yes, we got them correct.
Oh, okay. Woo.
So
All right, we're
Go
going.
us. We figured it out.
let me go back and you guys can
Oh yeah, tell you the
tell me
answers.
the yeah, that way
Yes.
I can,
Catch up. Okay.
yes.
Tell me when you're ready, McKenna. I'll go through them.
Okay. All right. Start. So 3 was 1? No.
3 is 1. Yes.
Okay. Then false.
Yes.
Then true.
Yes.
Then C.
Hmm.
Then
Then B.
B.
Hmm.
Okay.
Okay, and then next is 68.
68. 9.
Points 0.683.
Okay.
And then the next one is 0.955.
That's 10, right?
Yes, that's number 10.
Okay.
So 0.955.
Okay.
Okay. Question 11 is 0.997.
12 is A.
Yes.
13.
Is 0.238.
Okay.
And then 14 is 0.762. And then that's where we are.
Okay.
Yes.
All right. Thank you. So
Okay.
Okay, so let's finish this up. So 0.7 minus 0.65. Divide that by 0.07.
Oh, okay. Oh, it's
Okay,
the
so
same number but positive.
It's exact same.
0.71428. Okay.
so it's the same, just positive.
That would
Which
create the
makes
exact
sense
same.
because the mean is 0.65 and we had 0.6 before, now we have 0.7. So okay.
Is the same distance from
So
the
it's
mean.
0.714, right?
Yeah, but
Yes.
it's going to keep the lines exactly the same.
Yes.
So nothing changed. So it's everything less than this number, which was the answer we previously got. Correct?
So what do we shade? Or not
We would
shade?
shade everything to the left because we're calculating less than
Less.
0.7.
Okay. So did you guys get 0.7624?
Yes.
Really?
Yeah. What do you have?
Is anything, because isn't the z-score the same? So if the z-score is the same but positive, let me share 0.714. Okay, yeah, I gotcha. Yeah, so 7,
Okay,
6,
so it's,
yeah,
it's
you're right.
0.762.
Yes.
Yeah.
Okay,
0.762.
so 15 is 0.762.
Okay.
Find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7. So that's just the area in the center.
Yes. Yes.
0.525?
Yes.
0.525.
Okay.
Stop. Stupid. Okay.
So 35th
So-
percentile for the protein requirement for adults.
And we're going back to the book because I don't know how to calculate percentiles.
I know. Don't know what's going on there. Let's
Probability between two values. Calculating percentiles using a normal distribution. First, we need to find the z-score. It corresponds with the 90th percentile. All right, so click on the areas under the curve. What? We have our z-score, right? So the z-score is
Yeah.
714.
Yeah.
So I think we type in, because I mean, go to the textbook with me. Maybe make sure that I'm doing the right thing. So this is section 3.4.
Okay. Okay.
Okay, so we go into, there's a picture on the bottom of the normal probability applet.
Mhm.
So we are just typing the number under the area for the percentile that we want. Am I
Oh.
following that correctly? So
You're right.
0.35?
Yes.
So
Okay.
where would we type in point?
So we put it at the top in area, 0.3.
Oh, okay. So we're
Because
doing
we, right.
0.35.
Yes. And it's asking for find the 35th percentile, round your answer to 3 decimals.
Okay.
Okay.
So is that the 0.454?
Yeah, so you would. Yeah. So yeah, we type that number into the top, and then I think we use the z-scores that it gives us to calculate the rest of it. Okay, the z-score corresponding to this area will be in the bottom right. After you get that, you are taking your
So value minus the.
I liked it when they just wrote words. I don't like all these symbols that they put.
Yeah.
So it's the value and the mean, and then the standard deviation is the thing on the bottom. Am I looking at that correctly?
Yeah.
So z equals that. So we just have to reverse calculate it? Yeah.
Yeah.
Okay, so we have our z-score now. The z-score is the number that pops up there.
Which
Right.
is 0.454. Is that?
Yeah. So 0.454 equals, we know what our standard deviation is.
Where'd you guys get the 0.454?
When you
It's
type
after
in
you type in, when you
the
type in
area.
0.35, it pops up on the bottom under z-score.
My z-score is different.
So at the top of your applet,
Yeah.
put 0.35 and click
Yeah.
enter, and it should
Yeah.
change the z-score for you.
Yeah, but it's showing my z-score is 0.935.
You're in the first applet they had us open, I think. I'm confused at how these are different. But
Okay.
they
Oh,
are.
yeah, okay. And now I'm in the regular applet. I don't know.
Yep.
It must be different somehow. Okay.
They're different somehow, so yeah.
Okay, I'm there now. Okay.
Okay. So we have all those answers in 0.65, and we're calculating for x. So 0.454 times 0.7, or 0.07.
Times it?
Yeah, because we're reverse calculating.
Okay,
Write
so
out the entire equation. We're calculating for x, because we're trying to find the probability.
okay, so 0.454 times.
Yep, times 0.07.
Okay.
And then plus 0.65. Am I doing that correctly?
I believe so. Did you guys get 0.68178?
Yeah, but does that seem right? Because shouldn't the 35th percentile be lower than the mean? Because like this is what I have written down our equation. I don't know if that's reading to you guys backwards, but it's backwards on mine. It's 0.454 is equal to x minus 0.65 over 0.07. And then we're just reverse calculating it. So I'd take the value, multiply it by 0.07, and then add 0.65. Is that?
That sounds right to me.
Yeah.
Yeah. So.
Yeah, that sounds right. My formula was funky. I'm just going to do it really quick.
Well, they have a formula sample here too. So. Yeah, that's how they have it calculated in the book.
Okay. So would it, for the 35th percentile, it'd be 0.69, wait,
3 decimal places.
682.
Yeah.
Okay.
Okay.
And 80th percentile. So going back. 0.8.
Okay. 0.682. And then
Yep. So it's 1.282.
Yes. So then
So 1.282.
1.282. And then is it times?
Yep.
Times
So you're just doing the opposite of the equation.
times
Times
0.80.
0.07.
okay.
No, it's yeah, so it's 1.282 times 0.07.
0.07.
Yep. And then from there, you would add 0.65.
So, okay, so 0.740.
Yes.
Yeah, 0.740.
Okay.
And actually, now it makes more sense because you see the percentiles going up.
Yeah.
Yeah.
Okay.
Megan, do you want to submit?
Yes. 0.740 for the last one, correct?
Yes.
Yes.
Okay. Let's see what happens.
Please be right. Please be right.
Hopefully good news. Let's see. And we got the last 2 wrong,
Got the fart.
but the rest are correct. So almost there.
So lost. Like, what are we doing wrong here? All right.
The 35th percentile.
Because I'm looking at the solving for x portion of it. Because it says
Do we have it backwards?
we don't have everything highlighted. We have to highlight everything to the left.
That's what it is.
Oh, this darn. Okay.
Look at it, because if you look at the picture in the textbook, it's everything to the left of that.
You're
Yes.
right.
Okay.
Okay.
All right, we'll calculate for 0.8 because we're already here.
Yeah, so highlight everything to the.
Wait, because then it's 90%. I'm so confused.
So let's see. I'm gonna look at the textbook.
Got it. All right, so here's what you got to do. You have to highlight this middle and left section and then type in 0.8.
Okay.
Oh,
Because that's
okay.
your area distribution.
Aha. Okay.
Hey, are we ready?
So do you guys
we're-
have 0.842?
Yes.
Now we're doing question 18, then we'll go back and do 17.
Yeah.
Okay.
Okay.
So
Yeah. I have 0.842.
okay, so we're doing 0.842, right? Times?
Yep.
Or no?
Yep,
Times-
times 0.07 plus
Okay.
0.065.
0.65, right?
Yes.
Yeah.
Okay, so
0.656.
I got
No,
Point-
because we're using their the mean. So, oh wait, that's the answer that you got is 0.656?
Yeah, that's the answer that I got.
0.70894.
Oh. Yeah, let me
Right.
check mine.
I got the same thing, and yours sounds right, Megan. Oh wait, yeah, 0.709.
Yeah,
That's my answer.
that's my answer.
Yeah, that's McKenna. I had something different. I'm sure it's just my math. Let me see.
Okay.
Yeah, now I have it. 0.70894.
Yep.
Yes.
So rounding to
Okay.
3.709. All right, let's do this last one. We're so close, guys.
Okay, so okay, so it's 0.7.
I'm doing that. Not keeping both highlighted.
It's 709, right?
Yeah.
Yes.
Okay,
Yeah.
so 0.709. Okay. So now we're doing to the 30.
Are you guys running into the same problem with this, where it's not letting you?
Yeah, it's not highlighting. All
Not
of this.
highlighting the distributions that we need. What this?
Yeah, it's not letting me.
Oh, because 0.35 is less than 50.
Is less,
So,
right.
yeah, so it's not going to highlight that portion. 385? Is that what we used last time? No, it's not.
No.
We had something else.
Yeah, we had 0.454.
0.3.
Yeah. Okay, so 0.385
5 times 0.07
plus 0.65.
0.686. No.
I have 677.
That's, yeah. I have 0.6, yes.
Yeah. 0.67695. That's what I have as well.
Yes.
Okay. All right, Megan, you want us to get you caught up on all the other answers before you have to submit?
Yes. Let me refresh my page. I haven't. Let me go back to it.
Okay.
Okay. Oh wait. No, that's right. Okay. I thought I was clicking on the wrong quiz for a second. One sec. It's loading.
Okay.
Okay. Question 3 is 1.
Yep.
Then next one is false.
False.
Okay.
Then
Then
true.
true. Okay. And then
C and B.
C. And then B. Okay.
Then 68.
Okay. 68. Just 68, not like
Yep.
point.
68.
Okay. Oh, that's right. Okay.
And then
Yep.
9 is 0.683.
Okay.
Are you ready for 10?
Yeah. 10 is 0.955.
Okay.
Then your next one is 0.997.
Okay. And then first answer for 12.
Yep.
And then, okay, 13.
Is 0.238.
Okay. 14.
0.762.
Okay.
And 15 is the same answer, 0.762.
Okay. Okay. Then 16.
0.525.
Okay. And then we just figured out this one. And it was something.
0.677.
That's it. Okay.
Yep.
Got a lot of math doodles going on. Okay. And
Yeah.
then 18.
18 is 0.709.
All right, I'm submitting it.
All right, I'm going to add all these zeros to mine to make sure that it's right. Okay. I'll make sure
Oh,
I
yeah,
copy
that's
it.
right. Just so it
Good.
looks.
Formatting.
We got everything correct but 17.
How the?
We
know what?
still got 95% though.
I don't even care anymore. I'm submitting mine.
You know what? Yeah, let's call it. Let's say that's basically 100% in my book.
Yeah.
Seriously. We'll all still get an A in the class if we get 95s on all of these. So
Yeah.
that's good enough for me.
Awesome.
Yeah.
Well,
All right.
well done, everybody. That was
Yes.
not fun.
Yeah, quite the meeting. Okay. I'll have this link up in a minute or two.
All right, sounds good.
Okay, you guys take care.
All right, you
You
too.
too.
Thanks, guys. Good
All
work.
Bye.
Yep, bye.
Bye.